Hello friends, welcome to the board of EIGRP routing protocol. In this video we will look at the EIGRP concept and get to know how it functions as well as basic configuration of EIGRP, and also we will look at verification of EIGRP that works in layer 3 as you know. EIGRP or Enhanced Interior Gateway Routing Protocol is a Cisco proprietary routing protocol that was released in 1992. And its category in classless because they can support VLSM and routing, and also route summarization and load balancing. EIGRP is referred to as hybrid routing protocol because it has the characteristics of both distance vector and link state protocols, but now Cisco refers it as an advanced distance vector protocol. In the other words, this is a distance vector routing protocol with enhanced features. The main features are listed below. EIGRP can support VLSM, use reliable transport protocol RTP to delivery and also reception of EIGRP packets, use the best path selection dual, discover neighboring devices using periodic hello message to discover and monitor connection status with its neighbor, exchange the full routing table as at startup and send partial updates. Also can support multiple protocol for IP version 4, IP version 6, Apple Talk and IPX networks, and also load balancing. EIGRP has 5 packets, and when two router wants to be neighbor in EIGRP and enabling EIGRP, first shoot some packets to each other and exchange some packets together. And EIGRP use 5 types of packets to communicate. First, in this figure, first router A says anyone running EIGRP here with hello packet. With hello packet, router A send hello to router B and other neighbors and try to find neighbors. And this is an periodic multicast. After hearing hello from router A, router B will respond with another hello packet and say, yes, I have. Now they can find together. Then router B will also send its routing table to router A by update packets, and router B will send its complete routing table for the first time in the network with multicast. After that, router A confirms it has received the update packets by an acknowledge message or ACK. RA or router A will also send to router B all of its routing table for the first time and exchange its routing table. Then router B sends a message saying it has received router A routing table. And finally, router B sends a message saying it has, now both router A and router B learn all the routes of their neighbor and the network is conversed. And also you can see about query and reply. Query used to find alternate paths when all paths to destination have failed, and reply is sent in response to query packets to instruct the originator not to recompute the route because feasible successors exist. But to become a neighbor, they need to have this following condition. Following conditions are: router must hear a hello packet from a neighbor. In the second step, the EIGRP autonomous system must be the same. And also K values must be the same. But what is AS? What is K values? AS or autonomous system is a group of network under a single administrative control, which could be an ISP or a large enterprise organization. An IGP refers to a routing protocol that handles routing within a single AS, include RIP or RIP, IGRP, EIGRP, and OSPF. And in this situation, these four routers here under AS number 1 and these three routers is under AS2, and these routers is under both of AS1 and AS2, and this is the border router. But also we should know something about EIGRP tables. EIGRP tables, after you enable EIGRP, EIGRP builds and maintains three tables after enabling. Neighbor table that lists directly connected routers running EIGRP with which this router has an adjacency or neighborhood. We have also topology table, lists all routes learned from each EIGRP neighbor, and we have also routing table, lists all best routes from the EIGRP topology table and other routing process. Remember, EIGRP uses a default hello timer for 5 seconds and default hold timer of 15 seconds on LAN interfaces and 180 seconds dead and hello interval of 60 seconds. But how EIGRP find the best passes? How does Metic work? EIGRP uses Metic to calculate the best path between some routers and neighbors in the network. Each protocol implements its own strategy when it comes to metrics. RIP counted the number of hops, if you remember, or OSPF verified the bandwidth. But with EIGRP, Cisco tried to consider every possible item. In fact, the metric formula considers this formula. It consists of bandwidth of the link, the higher, the better, the load of the link, how much traffic is already using the link, the lower the better, and the delay, the lower the better, and its latency, and reliability, or how much we trust the link, the higher the better. But you can see this is very long formula. Delay is a measure of the time it takes for a packet to traverse a road. As administrators, we can change the K values to influence the metric calculation. Specifically, we can set them to be 0 or 1 to include or exclude an element from the calculation. By default, only Co1 and Co2 are 1. So you can see here. Another thing, by default, EIGRP metric evaluates only bandwidth and delay, and we should keep it this way. In fact, Cisco recommends to not check load and reliability and remove it from this formula. This is because these values change over time and they might make the network reconverge too often. Okay, and now this formula changed to this formula. Cost is 256, and only you can use bandwidth and delay in this formula. Finally, router 1 or router 2 or other router chooses the best path with the lowest metric. Configure EIGRP with IP version 4. Now we want to enable EIGRP and configure EIGRP routing. AS numbers are needed to exchange routes between AS, and it can be between 0 to 65,535. First, we should write here in configure terminal mode or global mode router EIGRP AS number. AS number should be same for all the routers in the network. And AS function as a process ID. And how to determine its router ID? All routers in the EIGRP routing domain must use the same AS number as I said. And also EIGRP router ID is used to uniquely identify each router in the EIGRP routing domain. Router use the following 3 criteria to determine its router ID. First, use the address configure with the EIGRP router ID. You can define it like this here, router EIGRP router ID, for example, 1111. After priority is, and second priority is, if the router ID is not configured, choose the highest IP version 4 address of any of its loopback interface. This is IP address of loopback. If no loopback interface are configured, choose the highest active IP version 4 address of any of its physical interface. This is a priority and you should remember it. After you enable router EIGRP with AS number, you should also define router ID here for each router. And also, we need to use network command here. After enable router EIGRP AS number, for example, for router 3, you should advertise the network here and use the network number or wildcard mask router config command to enable and advertise a network in EIGRP. For router 3, you should advertise this network that connected to router 3, this network that connected to router 3, and also this network. You have 3 networks here. You can see 192, 168, 10, 10.5, and 10.8. But what is wildcard mask here? Wildcard mask is similar to subnet mask, but is calculated by subtracting a SNM from 255, 255, 255, 255. For example, if you have subnet mask /30 like 255, 255, 255, 252, you can use this formula to calculate wildcard mask. And wildcard mask should be 0003. Yes, this one 255, 255, 255 minus 255, 255, 0, 255 minus 255, it should be 0, 255 minus 255 should be 0, 255 minus 252 should be 3. And in this situation, this is, for example, for router 3, this network, this is a /30, and you can calculate wildcard mask 3330. And for this router also, and advertise this network, you should write network 192, 168, 10.8, and /30, wildcard mask is 0003. And for this one is 000255. It should be here. Network 192, 168, 10, and wildcard mask is 000255. If you remember passive interface from RIP and also route summarization, about route summarization, summarization is a method to minimize the number of routing tables in an IP network As the network size increases, the number of individual network listed in the IP route table also increases, as does packet size. Routers cannot effectively handle a large number of subnetworks, which leads to slowdowns, packet losses, and even crashes. If you have, for example, 5 networks here, you can summarize it with only one network here, and you can use these common bits here. How many bits here is same? 22, and you can calculate it with 172, 16, 68 point or dot 0 s-22. No auto summary command to disable auto summary in EIGRP here. And also we have passive interface. Passive interface prevents EIGRP updates out a specified router interface. With this command, passive interface, for example G00, and routing updates from a neighbor are ignored. To verify EIGRP routing, you can use show IP route, show IP protocols, show IP EIGRP, show IP EIGRP neighbors, and a lot of commands. And to change bandwidth also, you can manipulate metric with this command, bandwidth and the value here, and you can manipulate it. And this is manually, you can change it. We should go to packet tracer activity. In this activity, we want to implement basic EIGRP configuration, including network commands, passive interface, and disabling automatic summarization. You will also verify the EIGRP configuration. First, we should go to router A here, and in global mode, you can write here router EIGRP and question mark. You can see what is your autonomous number. Autonomous number, for example, can be 1, but it should be same for router 1, router 2, and router 3. In the second step, you should define excuse me, just a moment. We have auto summary, distance, EIGRP metric, passive interface, and various. We have lack of some comments here, but important is here, you should advertise your network here. How to advertise your network? You can advertise your network with 192.168.10.4. And what is wildcard mask here? Wildcard mask for distance 4, this is 0003, and also we have other here 172, 16, 3, 0, and we have also 10. This is /24, and you should use this wildcard mask here. And also you should remember, what is your passive interface here? Passive interface here is G00 and no auto summary. Yes, we should disable automatic summarization here. And same process here also for router 2. Router, EIGRP, and what is wildcard mask? It should be same, excuse me, autonomous number. And network should be 172.16 to 0. All the networks that connected directly to router 2, you can see here, here, and also here. And this is 000.255. And we have other network here, 16 also 3. And this is wildcard mask is 0003. You can see you can get new adjacency with dual algorithm. This is log. And also you have other one here, 192.168.1.10.8 and 0003 here. Yes. And no auto summary. And passive interface is G00 for all of the routers here. And go to router 3, enable and configure terminal. And also you can use network router EIGRP 1 network 192.168.10 advertise this network and 0.00255, and we have 172.100. all of them is 192. 68 dot 10.4 and you can see the log here, adjacency, new neighborhood, and 10.8, and also this is same wildcard mask /cherry, and new adjacency here between router 1 and router 3 and router 2 and router 3. No auto summary, passive interface. Which one is passive interface and doesn't need to get any update here because this is computer and cannot participate in layer 3. And this is also G00. Yes, I have advertised directly connected, directly network connected to router 3, router 2, and router 1. For example, for router 1, it was this one, and this one that I have advertised. Okay, now we should go here and come back to exec mode, privilege exec mode. And right here, show IP routes to see what is the routing table here. D is EIGRP mode. You can see we have learned 192, 168, 10.8. Where is 10.8? This one. We have learned it from EIGRP and with adjacency with rotor 3 and rotor 2. We have also learned 10. This is 10 here. And this is the metric. This is the metric of this route using this interface. And this is AD, or administrative distance. For EIGRP is 90 by default. For all of them is 90, but cost is different. You can see this cost is different. This cost is different. Yes. Other network that we have learned here, this is 20 here that we have connected via 172.16.32. This interface that we have learned from serial 000 in on the rotor 2. And this is the cost for this pass. And C is directly connected, that we have learned it. And also this is local or interface IP address here, because it's also a /32. Also, it's the same in rotor 2 and rotor 3. Show IP route here. You can see also we have learned this tree network using EIGRP, and we can see also AD, administrative distance, and also cast, and with interface that we have help us to get adjacency. Also, if you write here show IP EIGRP neighbor, you can see what is your neighbor. Your neighbor for rotor 3 is 10.5. This is rotor ID, and also 10.8. If you remember in my PowerPoint, this is rotor ID, and we didn't set it because there is no command in packet tracer, not in reality, in packet tracer, virtual machine. And in this situation, we could not set it, and automatically rotor 3 has set them, and rotor 1 and rotor 2 set the highest number of IP address for rotor ID. And this rotor ID, it's here, rotor 1. This is rotor 1 rotor ID. And using serial 000, and this is the whole time, update time, and some information here. And also we have 10.9. 10.9 is rotor ID of rotor 2. And also we have other information here about, also we can see topology here. We can also see interface. What is your autonomous number? If you write here 1, you can see some information. If you can write here 2, you cannot see, because we have only autonomous number 1 here. And this is the other thing that help us in this situation. Also, you can write here show IP protocols, and you can see also some information what EIGRP you have used, what is the number, what is the formula or this metric. Call1 is 1, Call2 is 0, Call3 is 1, and what is bandwidth and some information and maximum metric and information here. Yeah, lots of. You can also see and try it. Yes, and in this situation, we have also verified that connection has been established. And you can use, for example, you can go here and try to ping PC3 from PC1. And click on fast forward. And you can ping PC3 because between routers, we need to have routing protocol, and our routing protocol is EIGRP, and using EIGRP, PC1 can ping PC3 and also PC2. (72) 16 2 10. I think this is IP address off. Yes, this is correct. And you can see here, PC1 can ping PC2 using EIGRP. Yes. We should come back to our EIGRP PowerPoint and quiz time. Which three metrics weights are set to 0 by default when cost is EIGRP as are being calculated? We have talked about that before, and only Call1 and Call3 and Call6 is, we don't have any Call6. We have Call1, 2, 3, 4, 5, and only Call1 and Call3 is 1, and Call2 and Call4 and 5 is 0. Which table is used by EIGRP to store all routes that are learned from EIGRP neighbors? EIGRP routers maintain a topology table that includes entries for every destination that the router learns from directly connected EIGRP neighbors. Yes, this is topology table. An administrator issues the router EIGRP 100 command on a router. What is the number 100 used for? As you know, this is autonomous number. And uses autonomous number to make connection, establish connection between all the networks under one domain, as you know. A network administrator has been asked to verify the metrics that are used by EIGRP on Cisco devices. Which two EIGRP metrics are measured by using static value on Cisco devices? Bandwidth and delay are static values that are not actually tracked by a device. Load and reliability are tracked dynamically by a device over default period of time. And also MTU is not used for EIGRP metrics, and answer are bandwidth and delay. Which command can be issued on a router to verify that automatic summarization is enabled? To verify if automatic summarization is being performed on a router, issue the show IP protocols. Show IP neighbor only show you what are your neighbor IP address and process ID and information about hello time, and show IP EIGRP interface also show you and give us some information. And IP interface brief is not about EIGRP, it's about get IP address of interfaces under router. This is not about routing protocol. Yes, thank you for watching, friends, and please subscribe me, support me, and have a nice day, friend.